What if I told you there was a formula that could solve any quadratic equation? Whether it's factorable, whether it has a b term, a c term, an a term, it can solve any quadratic equation of the form a times x squared plus bx plus c equals 0. And we call that the quadratic formula because it solves out all quadratic equations. Well, there is a formula that does that. That formula I'm going to give to you now. You can memorize it, I would, and use it. Using it's not bad, and in a later video we will use it. In this video, what I'm going to do is I'm going to show you where it comes from, how we solve for it, and what it does. So first let me tell you the answer. I know that's a little weird. Our answer is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And you might look at that and be like, oh my goodness, Mr. Groden, what the heck? This formula will give you the x-intercepts, if there are any, of any parabola. Any quadratic equation that you want to solve, that formula will give you the solutions to it. Now, I would only use the quadratic formula if we've already exhausted other techniques. If there's no b term, we can isolate the x by using the square root technique. If this thing factors, we should factor it and use the zero product property. If those fail, we use the quadratic formula. Now, I'm going to point out one other thing about the quadratic formula, and then for the rest of the video, if you so choose, I'm going to go through a challenging proof showing you why this formula is the solution to any quadratic equation, ax squared plus bx plus c equals 0. So again, to point out, this gives us the x-intercepts where any parabola crosses the x-axis, if it does cross it. It gives you the zeros, the solutions to any quadratic equation. But it gives you one other thing too. Notice this part here. I'll just kind of dot around it. Do you remember the formula for the vertex and the axis of symmetry? It is that formula. It actually comes from this. And I'm going to talk about that briefly. Then we're going to prove the quadratic formula. So you've got the opposite of b over 2a gives you the halfway point of any vertex. So let's say that we've got, not the halfway point, it gives you the vertex. Let's say that we've got that our quadratic formula has given us those two zeros. So what that means is we're a distance, the same distance away on either side of the vertex. What is that distance that we're on the either side? Plus or minus root b squared minus 4ac all over 2a. So we're either positive this value to the right or minus that value to the left. So where are we if we're in the middle? Well, we're neither plus that stuff or minus that stuff. We're right smack at minus b over 2a. That's one way of understanding why the vertex is where it is. Awesome. Okay, so it's up to you. You can turn off the video at this point and just say, I trust you, this formula works. Or you can buckle up and hang on for a wild ride. We're going to use completing the square to solve this equation to get the quadratic formula. Let's do it. So our goal is to get the quadratic formula. And I'm going to erase all these dotted lines here, at least some of them, so it doesn't distract. Get them out of here. All right, so we got some of those out of there. Okay, and then I'll repair it. So now our goal is to end up with the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we'll start out with our equation. This is going to take the whole board. It's going to be great. So we're going to complete the square. Now to complete the square here, it's a little difficult, so hang on. And you don't have to understand this to be able to rock the formula, but I want to show you. To complete the square, we're first going to factor out a. Now what I do is a little bit different than what I usually do with factoring out a. I'm going to factor it out from everything. So I'm going to factor out an a term, and that's going to leave me with x squared plus b over a, like that, right? So we've got plus b over a, x, and then we've got, well, plus c over a. And that's a little bit weird, I know. That's equal to 0. And you might be like, why would you do that? Well, first things first, a is some constant. It's just some number. So now I'm going to divide both sides by a. And the reason why I do that is if I divide by a, 0 divided by a is 0, and that goes to 1. So I'm left with x squared plus b over a times x plus c over a equals 0. And again, You don't have to understand this proof to be able to use the formula. In a later video, I'll show you how to use it. It's not hard to use, just funky looking. Now from here, I'm going to complete the square. When I do that, I have to, well, first complete the square part. I'll leave the c over a over here. And what I need to do is divide this by 2. So b over a divided by 2 is the same as multiplying b over a by 1/2, which is b over 2a. Interesting. That's kind of already in there. So let's see how this rolls into things. Well, what did we just add into the problem? Well, we just added in a b over 2a squared. So b over 2a squared, we'll do a little bit of side work, is b squared over 2 times 2 is 4a squared. So that's what I'm going to subtract from this side of the problem. So I get x plus b over 2a, all of that squared, minus what I just added in, b squared over 4a squared. Oh my goodness. And that looks gnarly, I'm sure. Remember that our goal though here is to solve for x. That's what we want to do. So what I'm going to do is I'm going to start writing on this side of the board here, up here, and now I'm going to bring everything on this side of the equation over there because we want to get x alone, right? So let's do it. So I'm going to add b squared over 4a squared and subtract c over a. That'll get rid of these values. So I've got x plus b over 2a squared. I'm going to add b squared over 4a squared. Oop, to the other side of the equation. So now I have an equals sign, right? So I have equals b squared over 4a squared. And then I'm going to subtract c over a. Oh man, that's beautiful. Okay, now what I'm going to do is I'm going to join these two fractions up. Why? Because I've got everything over one fraction over there. So that's going to give me, well, I'd have to multiply top and bottom by 4a to get 4a squared. Ugh. So that'll give me b squared over 4a squared minus 4ac over 4a squared. Ah, 4ac. We're getting there. We're building. It's all about asking yourself, what could I do? And it is gnarly, peeps. Okay, so this is now all over one fraction. So you've got b squared minus 4ac all over 4a squared. What we're also going to do, though, is we're going to refocus and recognize that what we're doing is we're trying to get x alone. So I have to take the plus or minus square root of both sides. Notice that completing the square led us here. Ah, check out what happens. We undo the square, we get x plus b over 2a is equal to, now this is plus or minus the square root still, right? But check out what happens. The top part does not simplify, but the square root of 4a squared is 2a. Oh, nice. And now the only thing we have to do to solve for x is subtract b over 2a. Oh my goodness. I'll jam that in there. So if I'm subtracting that, if you think about it, it's x equals the opposite of b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And since it's all the same denominator, we can combine it, and look what we get. The opposite of b plus or minus the numerator, b squared minus 4ac all over 2a, which is your formula. That's nasty. My purpose of showing you this is, one, if you're really into challenge, hopefully you're able to look at this and say, what can I do? What can I do? What can I do? And see how your solving skills can really be upped. It's hard. It's not easy. The other purpose, even if you're not fully understanding this, is to show you that these formulas don't just come from a textbook falling from the sky where you're all of a sudden like, oh, hey, it's a formula, it works, I trust my teacher. It comes from someone's thought, someone's brilliance to try this, to play, to mess around. That's how great progress happens. Somebody says there's got to be a better way to solving that, and they start playing. And it starts with struggle, and it doesn't always end up with a nice answer right away. It takes lots of tries. Amazing stuff.